Students, we are given this question. Prove that integral 0 to pi over 4 dx divided by a squared sine squared x positive b squared cos squared x is equal to 1 over ab tan inverse of a divided by b. So foremost, consider the left hand side, which is integral 0 to pi over 4 dx divided by a squared sine squared x positive b squared cos squared x. Now I'm going to be taking cos squared x out. So when I do that, this is going to be integral 0 to pi over 4 dx divided by, so cos squared x comes out, and that would mean I now have a squared times sine squared x divided by cos squared x positive b squared. So this is rewritten as 1 divided by cos squared x integral 0 to pi over 4 dx divided by a squared sine squared x over cos squared x is tan squared x positive b squared. Now 1 over cos squared x, you know that we have a trigonometric formula that 1 over cos x is equal to secant x, and 1 over cos squared x is equal to secant squared x, right? You know this. So because of this, 1 over cos squared x is rewritten as secant squared x times dx divided by a squared times tan squared x positive b squared. So you have a beautiful integration that you can easily perform by substitution. So what I'm going to do is I'm going to make the substitution, let u be equal to tan x. Now when you take u is equal to tan x, you differentiate both sides. Differentiating both sides, we get, so what do we get when you differentiate? Differential of u is du, differential of tan x is secant squared x times dx. So this is for du and this is for u. So therefore the question can be rewritten as, I'm not placing the integrals, the limits for now. So in the place of secant squared x, it's going to be du, and in the place of tan squared x is going to be u squared. So I also got a squared there. So it's going to be u squared positive times a squared positive b squared. The limits, we need to settle the limits. So how are we going to do that? Now when x is equal to 0, u is going to be equal to tan of 0. Now clearly tan of 0 is equal to 0. Now next step, when x is equal to pi divided by 4, u is equal to tan of pi divided by 4, which is equal to 1. So you have already got these limits. So because of that, this is going to be 0 to 1. Now what I'm going to do is I'm going to take a squared out of this. So this would be rewritten as integral 0 to 1 du divided by, I take a squared out, I get u squared positive b squared divided by a squared. I can rewrite this as 1 over a squared integral 0 to 1 du divided by u squared positive b squared divided by a squared. Now you would have studied this formula, which is integral dx divided by x squared positive a squared is 1 over a tan inverse of x divided by a. So using this formula in this integration, I would now have 1 over a squared times 1 over a is 1 over b divided by a, tan inverse of x over a is going to be u divided by b over a. The limits are 0 to 1. This can be rewritten as 1 over a squared times b over a, you can flip it, so that's going to be a over b times tan inverse of u divided by b over a. Again you can flip it, so you get au divided by b. The limits are 0 to 1. Now if you were to cancel the a's out, you will get 1 over ab. Now tan inverse of, substitute the upper limit, you get a of 1 divided by b. substitute the lower limit, tan inverse of a times of 0 divided by b. This is what you get. So now this can be rewritten as 1 over ab tan inverse of a over b. Why do I write that? Because this is going to be 0, so it will get cancelled out. So this will be the outcome. So you can simply write it, hence the result. Okay.